Hey guys, welcome back to another A-level maths video. This time we're continuing with doing every single exam paper that's ever come out. And we've done paper 1 and 2 of 2024, now we're moving on to paper 3. I was thinking of splitting this into stats and then mechanics as two separate videos, but I'm just doing it all together because that's what you're going to do in the real exam anyway. I decided to start with stats because I hate stats, so, start with what you don't like first so you can finish on something more enjoyable. But let's jump straight into it. Okay, Shan rolls a fair dice 10 times. The random variable x represents the number of times it will land on a 6. Using a suitable distribution for x, find the probability it's 3 or it's less than 3 for part A, I, and also for II. Now, when it says a suitable distribution, so again, we only really have two choices, really, which is the normal and the binomial. Technically, there's also the uniform distribution, which we could use on this. So we could use a discrete uniform distribution to work it out, but the thing is it's being rolled 10 times and the number of combinations for it to be exactly 3 is kind of a lot. So instead it makes more sense to split this into two parts, either getting a 6, so let's call it S, or not getting a 6, let's call it S apostrophe. So two options means it's a binomial distribution, so we want the probability that we get a 6, so we're going to use a binomial distribution. The reason why it's important to actually write this down is because, in fact, I wrote those two letters the wrong way around. You do actually get a mark for that. So you might notice there's 3 marks here. The reason why there's 3 is because you do get a mark for just writing down what your distribution is going to be. So it might be a smart thing to do just in case you get the wrong answer or your calculator has a bit of a glitch. So there's a 1 in 6 chance of getting a 6. So for the first one, getting x equals 3, well, that's nice and easy. We can go straight to our calculator, go down to distribution, option number 7. I'm also aware that the new calculator is slightly different to this, so you should still be able to, but it has the same options, just in a different place. Binomial PD, remember when you want an equal sign, so you want one specific value, you're going to use PD. If you have an inequality, you'll use CD. So this time we're going to use PD. We're going to use variable. X is going to be 3. The number of times we're doing it is 10. And the probability is 1 over 6. Enter that, you get 0.155. I would probably recommend giving it to 4 decimal places, so 0.1550. Now for part 2, again, luckily, it says less than 3. Now in the calculator, your calculator can only do less than equals. So instead, because it's a discrete value, what's less than 3? Well, it's going to be 2. We can't have 2.5 or 2.6 because it's the number of times we do something. We can't do something 2.5 times. So we're going to have probability that x is less than or equal to 2. Which will make a big difference for the binomial. It doesn't make a difference for the normal distribution though, but we'll get onto that. So binomial CD this time. CD stands for cumulative distribution, so it's up to and including a value. In this case, up to and including 2. Variable, this time we want 2, everything else is the same, so we get 0.7752. And there you go, 3 marks, not too bad. So, Qian repeats this experiment each day for 60 days and records the number of days when x is equal to 3. Find the probability that there are at least 12 days when x equals 3. So this here, you can represent this as another binomial distribution. Because again, either it equals 3 or it doesn't equal 3. Because there's 2 outcomes and there's a fixed number of trials, 60 days, and there's a fixed probability, so we're assuming that the dice rolls are going to be independent of each other, which makes sense, right? If I roll a 6, it doesn't change the probability of getting a 6 the next time. And we also have a fixed value that we want, which is at least 12. So we're going to call this, I don't know, D for days. It doesn't really make much of a difference. We've done this for 60 days. The probability is when x equals 3, so 0.1550. And we want the probability that D, it says at least 12 days, so greater than or equal to 12. Now I mentioned that our calculators only do less than equals to, which means we can't actually do bigger than or equal to 12. I realise that kind of looks like a bracket. Let me rewrite that again. So bigger than or equal to 12. So instead, I like to use a kind of a number line to visualise this a little bit. But what we want to do is, put it this way, the probability of getting more than or equal to 12 plus the probability of getting less than 12 should equal 1, right? Because if you think about it, either you roll a 6 on 12 or more days or on less than 12 days. That's the only options, right? Because this covers all the way from 0 days all the way up to 60 days getting a 6. So if I rearrange this, this probability here is the same as 1 minus the probability of getting less than 12. And the reason why that's useful is I can actually work this out assuming I change that to d is less than equal to 11, because remember, I can't do less than, it's less than equal to. So it's very specific. So if we just do that, we actually get our value. Sometimes I show students how to represent this as a number line to get this result, which again, if you like, I have got a video going through this specific topic. Have a look at the video. This is a different way to do it, which is using more of an algebraic way, so using an equation. So what we're going to do is we're going to work out what d less than equal to 11 is going to be. So again, we're already on binomial CD, so that's lucky. X is now 11, n was now 60, and the probability was 0.1550. So I get 0.7885 if I round that. By the way, I am just going to use the answer button to get the actual value. So, and we get 0.2115 as our final answer. So yeah, not too shabby there. For part C, it does say, find an estimate for the total number of sixes that Xian will roll during these 60 days. Okay, so in this case, he's rolling a dice. It does say he's doing it 10 times, but he's rolling a dice once per day. So there's a 1 in 6 chance that he gets a 6. And he's doing it 600 times, right? So again, the probability of getting a 6 is 1 over 6, but he's doing it 10 times each day for 60 days. So in total, he's rolling the dice 600 times, right? So if he's going to get a 6 roughly 1/6 of the time, then it should be a 1/6 of 600. So again, total number of times he's doing it, well, he's doing it for 60 days, so that's where the 60 comes from, but he's doing it 10 times each day, which is 600. And again, the probability of getting a 6 as an estimate is going to be 1 over 6. For part D, normal approximation. Okay, so in fact, it might actually be easier for me to write the answer to part D along the side here, just so we can see the whole question. If only this was an option in your actual exam. Use the normal approximation to estimate the probability that Xian rolls a total of more than 95 sixes during these 60 days. So with the normal approximation, obviously we're going to have to work out a few things. But before we do that, I'm going to check out how many times, like the other variables for this. So we're going to say, what should I call it? Should I call it S? Maybe. I might just call it, it says total, so why don't we do it as a T, right? Normal distribution, and if you remember, normally, that's what you need for the normal distribution, right? You need mu sigma squared. Now, mu in the normal approximation is just NP, and if you remember rightly, in total we're doing it 600 times. The probability of getting it is 1 over 6, so it's going to be 600 times 1 over 6, which we've actually already done. It's 100. And sigma is a little bit harder. The way you do that is you do sigma. Just so you're aware, you do get given this equation in the formula sheet, so you don't need to memorize it. And it equals it. Okay, the equation you get given is sigma squared is equal to the square root of np1 minus p. But I think that's a bit unwieldy, so let's just write it as sigma. And we're going to work out the value of it now. So, cool. We have square root. So we know np is already 100, so I'm not going to do that again. Times, I forgot to put the close bracket, whoops, and then my calculator's gone. 1 minus p, so that's going to be 5 over 6, right? And we get 9.1287, let's call it. Cool, so now we know what mu and sigma are in our kind of calculation. That's wonderful. So now all we need to do is work out the probability of getting more than 95 sixes. So we're literally working out the probability that t, it says more than. Now, those of you that have kind of a good understanding of this know that more than and more than equal to is actually the same thing for normal because it's continuous. But, it's fine. So distribution, normal CD, because again we want, we have an inequality. The lower value is 95. The upper value technically can be anything, so let's just enter a massive, massive number. Sigma was 9.1287. and mu was 100. And we get 0.708. Let's call it 0.7081, because I've done everything else to 4 decimal places. Let's do this to 4 decimal places. Okay, go back a little bit. Back to here. Okay, so now when we're putting this into our calculator, we need to do something a bit clever, because don't forget the normal approximation. We want to work out this. And again, before people get angry at me in the comments, that's what we're working out. But remember, with the normal approximation, the problem is when we go from binomial to normal, we're going from discrete data that takes specific values to continuous data, which can take any value. Now, of course, the number of 6s you get can't be continuous. But again, that's the approximation we've used, so we have to pay the consequences. That means we have to do this. You add 0.5 to whatever boundary you have. So if we go back and fill it in on our calculator, again we have normal CD because we have an inequality. The lower value is 95.5. The upper value is just a huge number. Sigma is 9.1287 and mu is 100. 0.6, I don't really want to do that to 4 decimal places now. I'm going to call it 0.689. All because I don't want to change all the values. And there you go. That'll be it for 4 marks. Not too bad, hopefully. Okay, so here we have the PMCC question, or kind of the correlation question. Amar is studying the flight of a bird from its nest. He measures the bird's height above the ground, h meters at time t seconds for 10 values of t, and he finds an equation of the line to be 38.6 minus 1.28 t. What would the gradient of the line represent? Now again, you have to be very, very careful with this, because when you work this out, you need to be very specific about what the gradient is. It's not just, oh, it decreases by 1.28 meters, right? Although that is what's happening, you need to be very, very specific. You would say the height of the bird decreases, and you do have to specify decreases, not just changes, by 1.28 meters per second. So can you see how I've used everything from the question? H is height in meters at time t seconds. So the height of the bird decreased by 1.28 meters per second. You have to be very, very specific, because otherwise they can just say, well, you know, you've just memorized some kind of outline or some kind of sentence starter. The PMCC between H and T is negative 0.510. Test whether or not there's evidence of a negative correlation. So of a negative correlation. So this is a one-tailed test, not two-tailed. Between the height above the ground and the time during the flight, you should state your hypotheses clearly, use a 5% level of significance, and also state the critical value used. So, first of all, hypotheses to get 1 mark. The null hypothesis for a PMCC test is always that there's no correlation. That's what we have to assume to be true, because we have no evidence for a correlation until we've done the test. So there's no correlation until we've done the test. Hence, null hypothesis is always rho, the PMCC equals 0. There's no correlation. Now, because we're testing for negative correlation, we're going to make that less than 0. Cool. Now what do you do? Well, you have your 5% level of significance. You should also have a... actually, no, that's all you'll need for this. And you also have a sample size of 10. So you have a 5% level of significance, sample size of 10, because there's 10 values of t. Then what you need to do is you go to your formula sheet. It's also in the back of the textbook if you haven't printed out your formula sheet yet. I would recommend printing out the formula booklet because it's 48 pages long, and you kind of need to get used to finding different things. And you should have a page that looks like this. Now, we don't care about the Spearman's coefficient. I'm assuming you're not doing A-level stats as well, as in the actual statistics A-level. And as you can see here, it says level and sample size. So our sample size was 10, so we're looking at this row of values here. Thanks, Adobe. And the level refers to the significance level. Now, if it was a two-tailed test, we would have to half the significance level, but it's not. So we're looking at the 5% significance level. So we're going to go to 5% significance level. I'm going to go down to 10, which gives me a value of 0.5494. Now, you might notice, as a critical value, it's a bit weird because all of these are positive. There's no negative ones. The good news with this is the positive value and the negative value are the same. So for example, 0.5494 and negative 0.5494 is, you get both values from here, right? So I'm going to write critical value is 0.5494. Okay? Now again, because we're doing negative correlation, it's obviously not going to be positive, right? Like there's no way it's going to be positive. So instead we're also going to use the negative 0.5494 values. Now, here's where students get confused. Because when you do this this hypothesis test, your critical regions are a bit weird. It's either bigger than the positive value or less than the negative value, and people forget it. And when they forget it, they make a mistake in the exam. Let me explain why really, really quickly. Again, if you think about what we're doing, and I don't mean to sound really sarcastic there, but if you think about what we're doing, it will make a lot more sense. That means you won't have to rely on your memory, and you won't forget it. Now, I know what you're thinking, oh, it's fine, I'll memorize it before the exam. You're going to say that about a lot of different things, and the problem is your brain, it's not very reliable. You know, even in court, they don't really trust witness statements all that often because of how unreliable human memory is. So when we're doing something important, like a maths exam, you don't want to rely on it. I'm not going to go all the way up to... It should go all the way down to -1, right? But my hand's getting tired and you're probably getting bored of watching me draw a number line. An awful number line, but a number line nonetheless. Now, when we talk about correlation, it goes between -1 and 1, where 1 is perfect positive correlation and -1 is perfect negative correlation. So in other words, the bigger the number, the magnitude of it anyway, the bigger the number, the stronger the correlation. So we've got these critical values at 0.54 and -0.54 over here, right? Now, between those values, is the correlation stronger or weaker? Well, it's weaker, right? So for example, a correlation of -0.2 is weaker than a correlation of -0.54. And a correlation of 0.54 is stronger than a correlation of 0.1. So in other words, between these values, we have a weaker correlation. So would it make sense in our hypothesis test to accept values between those two limits? Because when we're testing, we want to test for a strong correlation. So we want this number to be as big as possible in terms of its magnitude. In other words, we want it to be as close to 1 or -1 as humanly possible. Does that make sense? So for example, all of these values here would indicate, all the way up to 1, would indicate a stronger positive correlation, which is why we accept values bigger than the positive number. But because we have negative correlation as well, it's not just only values bigger than that we accept. It's also, over here, we still have really strong correlation. It's just negative correlation. That's why we accept values less than -0.54. Because when we say less than, don't forget, it is bigger in a sense. It's bigger in the sense that it's stronger negative correlation. It's not just less than in the sense of being smaller. So that's why it's less than the negative, greater than the positive. Because we're looking for the strongest form of correlation. So we want the values closest to -1 or 1. Either one of those. It's not going to be, it can't be both, because obviously correlation can either be positive, negative, or nothing. It can't be, it can't be neither. Both at the same time. So looking at this, we have a value of -0.5101. Now, is that less than -0.5494? The answer is no. So because -0.5101, 510 even, is bigger than -0.5494, then we have to say insufficient evidence to support the claim that there is a negative correlation between the height above ground and the time during flight. In other words, there's insufficient evidence to reject the null hypothesis. Now, when I've stated that, and I say this a lot with hypothesis testing, they've become very strict on the wording. You can't say reject H1, because that doesn't make sense in terms of mathematically, because we're not saying H1 is true at all. We're testing if the null hypothesis is true. So we reject or accept, we reject or don't reject the null hypothesis. We never say reject H1. Now, you used to be able to get away with that, now you can't. So in this case, we say there's insufficient evidence to reject the null hypothesis, or insufficient evidence to support the claim that there is negative correlation between the height above the ground and the time during the flight. And you do have to word it that way. God, man, I love stats, don't you? How specific with the wording you have to be. Jane draws the following diagram for Amar's data, and we get this kind of almost like a negative quadratic. With reference to the scatter diagram, state giving a reason whether or not the regression line is appropriate model for this data. Well, this is a straight line graph. Does that look like a straight line? So you say no, because it's not linear. Or not straight line. Right? It looks more like it's quadratic or something like that, as I said before. Jane suggests an improvement to the model using the variable u is equal to t minus k squared. So she's still going to use a linear equation, but it's not actually linear because u is a quadratic. So, cool. Choose a suitable value for k to write Jane's improvement for the model in terms of h only. So, in other words, we have h is equal to 38.1 minus 0.78. Then we have t minus k squared. They want the only variable to be t, so we need to get rid of k. Now, if we look at this, what does this equation remind you of? Because it reminds me of completing the square. So what does that mean? Well, it means that the maximum value, and it is a maximum because don't forget this is a negative quadratic, so it's a sad face, which means it's a maximum value. The maximum value should be at k 38.1. So what if I just look at my graph here, look at where it reaches 38.1 or reaches its peak, and just read off the value of t? Right? So all I need to do is I need to just read this value off. Right, zoom. So it looks like it goes up in 0.2s, right? 3.2, 4, 6, 8. Good. So this should be 3.5, I would say. And they do give you a mark for anything between 3 and 4.5. So, you know, that's what I got, right? There you go. Hopefully that makes a bit of sense. Again, use a lot of your pure knowledge in order to answer stats questions. There's more overlap than you think. Okay, the large data set question. And in total, there's always going to be 3 marks, where the only way to get the marks is from knowledge of the large data set. So here, it's part A, using your knowledge of the large data set, and part C. The only way that you can actually work this out is by just knowing the large data set. So I'd recommend going back and just basically doing all of the questions for it. I do have access to every single past question with explanations and things like that I might put online for you guys or something like that. Because honestly, it's the only way to do it. Even for me personally, I don't even know that much about the large data set myself, because when I learnt it, I basically forgot about it immediately because it's literally just a list of facts. That's all it is. There's no real mathematical knowledge needed for it. It's just memory. And so I'd recommend just doing all of those questions regularly, so that way you can get those 3 extra marks, because who knows how many marks you'll be off from the next grade, right? It could be 3, it could be 2, it could be 1. So here we have, it says air temperature, but they selected the wrong thing. It actually gave a mean of 5.3 and a standard deviation of 12.4. So yeah, wonderful. It's not temperature. What could it be? It's the rainfall. And again, these are just facts that you need to know. There's nothing else to it. So the next part, though, we can actually work this out without knowing anything about the large data set. So we get half marks at least, 3 out of 6. The correct values are this stuff. Calculate the mean and standard deviation. If you remember, the mean is just the sum of the variable over n. They've given us both of those, so it's really nice and easy to work out. We can literally just do 2801.2 over 184. And we get 15.22. Does it say how many decimal places? No, so I'm just going to write 15.2 then. And the standard deviation, you do get a formula for the standard deviation, but whether or not it's useful to you is another story entirely. But it's the sum of x squared over n minus basically what we just worked out, the sum of x over n all squared, which if you notice is literally just the 15.2. So I'm going to absolutely use the answer button because I'm lazy. But again, lazy is good. So we have 44695.4 over n, which is 184, minus then the answer button squared. Gives me 3.34, let's call it. There you go, for 3 marks. That's not too shabby. Now, again, part C. That's not part A. That's part B. For part C, one of the months from the large data set of Perth has a mean of 19.4 and a standard deviation of 2.83, and it's the mean air temperature. So just giving a reason a month these data might have come from. Now, there is actually something kind of interesting with this, which is people get the right reason but the wrong month, because they say that they use their brain and they're like, you know what, that's quite high. 19.4 average thing, that's quite high, it must be summer. So their reason's right. So it's a high mean temperature. They get a mark for that, but then they say it's summer. Where in the world is Perth? It's in Australia, the southern hemisphere. Their summer is our winter. So in actual fact, the hottest time of year for them is like October, November, December time. It's not July, which is... It's weird that that's how it works, but that is how it works. So in actual fact, you would say it's like October or some other time, right? Because the opposite of July or June is October. Yep, fun question. I love it. And of course, we have the hypothesis testing question. This is one of those topics that's guaranteed to come up. The large data set's also guaranteed to come up, as well as the normal distribution. So just so you're aware, there will be 1000%, there will be a binomial or normal hypothesis testing question. Always, every single year, guaranteed. And there's also always going to be 3 marks on the large data set. So we have to do a hypothesis test call. Again, for 1 mark, you can just write down your hypotheses. So if you're completely lost on a question, just write down. So the proportion of left-handed adults is 10%. Okay. But this person believes that it's different from 10%. So in other words, not equal to 0.1, which means it is two-tailed. There you go. 1 mark. Nice and easy. Now, sadly, this isn't a proper hypothesis test, in air quotes. You have to find the critical region. The reason why I say that is people find critical regions harder than just doing a normal hypothesis test. But if you end up doing this in real life, so if you go into anything related to science, some kind of research or something like that, or stats, you will have to write your critical regions down before you do your experiments. It's just good practice. So let's see. We want a a significance level of 5%, so we're actually looking at 2.5%. So there's going to be a value where the number of left-handed people is less than n, which will give me a probability less than 0.025, right? There's also going to be a value of x greater than which we have a probability of happening that's greater than 0.975. Now, critical regions, why are these so difficult for people to understand? Because I think the way hypothesis testing is taught is a little bit crap. It's not really accurate to what it means. If you think about this, think about what this statement is saying. We're saying the probability of getting less than, let's say, 3 people being left-handed is 2.5%. So we're saying it's so unlikely that the null hypothesis is likely to be false. That's what we're saying. Or alternatively, and when we say false, by the way, we actually mean that the proportion should actually be less than 0.1. Now in this case, let's say again, the probability of getting more than 10 people to be left-handed in this group of 40 people is so unlikely as well that it's more likely that the probability is actually greater than 0.1. So here's how we do this. The reason why I wrote 0.975 is because when we do our calculator in a second, we can't actually work out values less than. So if I write the values less than 2.5%, it only gives me this one. It doesn't give me the bigger one. So here's how I do it. Menu. I actually write this out first. So we're looking for 2 regions. One where it's less than 0.025, and 1 where it's greater than 0.975. But remember, we want less than 0.025, but as close to 0.025 as possible. And for this one, we want bigger than 0.975, but still as close to it as humanly possible. So we go down to distribution. This is a binomial because, of course, you either have left-handedness. That doesn't make any sense. You're either left-handed or you're not. And we're going to go to binomial CD. Now we're using list. List allows me to write down every single possibility. So it's possible to have no one be left-handed. 1 person, 2 people, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to do this all the way up until 40. To save your time, I'm just going to skip ahead. And there we go. Now, again, if you've watched my video on doing this, you'll know that you actually don't need to write in every single value, and you can kind of guesstimate where it is. And if you attend the same school I do, or you do my tuition lessons, I've shown you ways on how to actually get accurate values for this without typing all of them in. But I don't really have time to go through that now. So, press equals, n is out of 40, and what's the probability? We're going to say 0.1. Now, when you do this, your calculator might die for a second. There we go, that wasn't too bad. And all we're doing is we're looking for the value closest to 0.025, but still less than. Well, as you can see, it's 0. So basically, if 0 people... actually, it's technically equal to, isn't it? Yeah. If 0 people are left-handed, then that means chances are this probability is wrong. It's actually less than 0.1. So our first critical region is x less than 0. Or x equals 0 if you really want. So either less than equal to 0 or just equal to 0. Now we're going to do the 0.975 one. So we're going to go all the way to the end. See what I mean by you don't need all the values? It's not even that bad. There we are. So 9845, and then it goes below 975. So we're looking for x being greater than equal to 8. Yes. So it's greater than 8. So n equals 8. So the other critical region is that you can either say bigger than 8 or bigger than equal to 9 or just bigger than 8. Either one of these is the same thing. So yeah, in terms of the actual probability, which I probably should have written down, whoops. The actual probability for this one, what's 1 minus 0.9845? That would be 0.0155. And what was the one for 0? 0.147. 0.147. There you go. Okie doke. There you go. That's it for part 4. Now, in terms of the actual significance level, what do they mean by that? Well, if you notice, our probabilities here, they don't add up to 2.5%. Neither of them are 2.5%, and they don't add up to 5% either. So instead, we're going to work out the actual one, which is where we just add those two values together and make it a percentage. So let's 0.0147 plus 0.0155. We get a percentage of 3.02%. And then in Freya's sample, 7 adults were left-handed. With reference, comment on her belief. So again, basically saying the conclusion. Well, it's not bigger than 8 and it's not 0, which means insufficient evidence to support Freya's belief. That's it. And now, of course, a normal distribution question as usual, which means the next one's probably Venn diagrams or conditional probability. So anyways, we have the records for a school athletics club show that the height achieved by in the high jump is normally distributed with a mean of 1.4 and a standard deviation of 0.15. So find the proportion of these students achieving a height of more than 1.6 meters. So literally just find the probability that the height is more than 1.6 meters. Which is, again, just something you need to shove into a calculator, not too shabby. So down to distribution, normal CD, the lower is 1.6. Make sure you enter a really big number for the upper, just to make sure nothing weird happens. Sigma is 0.15, and the mean is 1.4. We get 0.0912. 0.0912. The records also show that the time t seconds to run 1500 meters is normally distributed with, again, a mean and a standard deviation. The head would like to use these distributions to estimate the proportion of students who can jump higher than 1.6 meters and run 1500 meters in less than 5 minutes. State a necessary assumption. So the assumption here is that h and t are independent of each other, which is actually a bad assumption. But, for example, it will skew the data if running 1500 meters quickly helps you in the high jumps and it helps you like jump higher. Now, of course, logically speaking, they probably aren't independent if you think about it. Like, if someone can run, it means they probably have pretty strong legs, which means they should be able to jump, I would imagine. But yeah, basically they need to be independent and find the head's estimate of this population. So we need to work out, so first of all, if you want both of them to be true, if you remember back from your GCSE probability, it means you're going to take the probability of one thing and times it by the other. So we also need to work out the probability that it takes less than 5 minutes for someone to run this quickly. So it's in seconds because, again, the mean and standard deviation are in seconds. There we go. So we want the probability that t is less than, not 330, 5 minutes would be 5 times 60, 300 seconds. So let's find that out. So lower, again, is going to be negative, really big number. The upper is going to be 300. Standard deviation was 26 seconds. Mean was 330. 0.1243. And so the probability of both of them happening is just those two probabilities multiplied together. Because again, it's like an and, right? Whenever you say and, it means the probability should go down because you're being more specific. So answer is that, yeah, times 0.0912. 0.0113. Yeah, 0.0113. Perfect for 3 marks. Now, this happens quite a lot, where they're going to give you, essentially you're going to have to use the standard normal distribution in order to work out mean and or standard deviation. In this case, we want both of them, which is a bit terrifying. But again, you do it in the exact same way. So, what you do is use the standard normal distribution to work out what this value is here. And if you remember, the standard normal distribution uses coding, where z is equal to x minus mu over sigma. So what we're going to do is we're going to find out the z value that gives us 0.3 first. Now, if you remember with the normal standard distribution, you are using the, first of all, the inverse normal distribution. The area is 0.3. Sigma is 1, mu is 0. Okay, that's the standard normal distribution. Now, when we do this, we're going to get a negative value. We could also get, but we need to decide if we want the negative or the positive value. The way you decide is quite simple. The standard normal distribution is centered around 0, which means it's symmetrical around 0. So it looks kind of like this. Now, when we say, hey, calculator, can you find me a probability of 0.3? There are two different regions, right? That region will be 0.3, as will that region. Now, of course, now we have to keep one thing in mind here, is our calculator always does less than. So when it does less than, it's either going to give me this region here, and to get this region, it would actually have to give me the probability of all of this being true, which would be 0.7. So in this case, because we have 0.3, we actually keep it as the negative value because we're looking for a less than area. So again, if the probability is for a greater than area, so like this, you're going to take the positive value. Even if it's negative, you make it positive. And if it's a less than value, that means you're looking on the left side, it's going to be negative. Again, less than means it would be on the left-hand side, greater than would be on the right-hand side. So that 0.3 gives me negative 0.5244. So x is going to be 16.3. I don't know what mu is, and I don't know what sigma is, of course, but that should equal the negative 0.5244 that I calculated. Now we're going to do the same thing with this one, but again, remember, I'm going to get a negative area. but I don't want the negative area. I want the positive one because we're looking for greater than. Greater than would be the area on the right hand side. So that'd be this part here, 1.282, let's call it. And that would be 29 minus mu over sigma equals 1.282. And now we just need to solve the simultaneous equations, which isn't as bad as you might think. What I would do is I would use my calculator to do it. So I'm going to move the sigma over and move the mu over. So we have 16.3 equals negative 0.5244 sigma plus mu. And here we would have 29 equals 1.282 sigma plus mu. Of course, we could just subtract and then work it out the normal way, but I'm going to show you a way to do it on your calculator just because that might be a bit faster for you. Equation/func, simultaneous, two unknowns. Let's call sigma x, so 1.282, and negative 0.5244, 1, and 16.3. So as long as you have it in that format, you can always just work it out on a calculator. Again, you don't have to show yourself working out the simultaneous equation in stats unless it says solutions based entirely on a calculator are not accepted. If so, this is a really easy simultaneous equation to work out. You just subtract the two equations. Cool. So here we get sigma is 7.03. The reason why it says x, remember, is because we said that mu is x. And mu is 19.99, let's call it. And there you go. Not too bad. And lastly, we have Venn diagram, conditional probability, whatever, same thing. And they give us this disgusting looking thing. So we have D that's nested inside E, at C even, a bunch of other stuff, cool. And it says state any pair of mutually exclusive events. So remember, mutually exclusive means that they both cannot happen, which means on a Venn diagram, there will be zero overlap. So for example, C and A would be mutually exclusive. B and D, A and D would also be mutually exclusive. So any combination of those works. So if they don't overlap, then that means they're mutually exclusive. Remember, D and C, they do technically overlap because D is a sub event for C, right? So it could be, for example, C is a probability it rains, D is hail, specifically, for example. Anyways, B and C are independent, find the value of P. So when they say B and C are independent, that means that there's a special equation, which is the probability of B times the probability of C gives us the probability of B and C happening. So in other words, the overlap will be equal to those two times together. So we can actually work that out. The probability of B happening is P plus 0.27 plus 0.05, so that's 0.32 times the probability of C happening, which is, you know what, screw this, I'm not gonna. Why am I being a peasant for? Why can't I just, use a calculator? 0.08 plus 0.225 plus 0.27 gives me 0.6. Okay, I guess I didn't need that, but it's fine. B and C is just just 0.27, and now all we need to do is expand, simplify, move it over. So I could write this as 0.6p equals 0.27 minus 0.6 times 0.32, and then because I'm lazy, I'm just going to divide both sides by 0.6. So we have 0.27 minus 0.32 times 0.6. That gives me that, divided by 0.6 again, 0.13, which is indeed correct. So what I'm going to do is, and I'll do this on my papers, I've crossed that out and I'll write 0.13. That way I'm not getting confused between all the different letters. Cool. That's perfect. Then for part C, it says find the greatest possible value of A given not B. So remember, to work out that, you're going to do the probability of A divided by the probability of not getting B. So probability of A is just everything inside the A bracket, or whatever you want to call it, which is don't forget it's given, not b, so it wouldn't be including 0.05, so just be q. And then over everything that isn't b, which is q plus r on the outside, plus 0.25 plus 0.08, so that would be 0.33. Yes. And it says find the greatest possible value. So, in fact, do I want to leave it like this? Yeah, that should be fine. Let's see. What else does it say? Yep, that's pretty much it. So, where do we go from here? So again, hopefully that first part makes sense. The reason why for probability of A I didn't include the 0.05 is because it says given that it's not B, so we immediately take away everything inside this circle there. So where can we go from here? Since it says find the greatest possible value, that means we're not actually working out the answer. So we're not working out Q or R, we're trying to work out what the greatest possible value of those is. Now, the other thing that we can say is that all of the probabilities in here should add up to 1. So in other words, I have Q plus R plus, in fact, if I add all these up now, so that's 0.05 plus 0.13 plus 0.27 plus 0.25 plus 0.08, I get 0.78, should equal 1. So when it comes to Venn diagram questions, always use like the whole independent thing, but also use the probabilities add up to 1. If I don't actually need it for part C, I'll probably need it for part D, E, or F, right? So it doesn't really make much of a difference. So that means Q plus R has to equal 0.12. 22. I promise you I can do basic maths. Promise you. Now, we know that R is bigger than or equal to 0. Right? It has to be, well, it can't be negative, right? Which means Q is less than or equal to 0.22, right? Because, for example, if R is 0, then Q is 0.22. But if R is 0.1, for argument's sake, then that reduces the value of Q. So we can use that to work out, essentially, the bound for this. So if I want to make this as big as humanly possible, I want Q to be as big as possible. And I want the denominator to be as small as possible. So essentially what we're going to do is we're going to say that it's, well, if Q is going to be 0.22, let's sub that in. We get 0.22 over 0.22 plus 0.33. I can't do that in my head. Or can I? No, I can't. I get 2/5 or 0.4. So that's the greatest possible value of that thing there. Perfect, because again, we want the numerator to be as big as humanly possible. Now it says, given that B, probability of B, given that it's not A, is equal to 0.5, find the value of Q and R. So again, we're going to do the exact same thing that we did before. We're going to use the fact that that would be the probability of B over the probability of not A. And again, when we do the probability of B, we're not going to include A in it. So that means we're going to use 0.13 plus 0.27. Again, we're not including that. So 0.13 plus 0.27 is 0.4 over all of the probabilities that aren't in A. So if you'd like, you can just highlight this. You're looking at everything outside of that region, which would be R plus then all of that other BS, all that other stuff. So if we add that up, we have, again, just because I'm being lazy, .73. Cool. And we know that that should hypothetically equal 0.5. So now we can work out what R is, right? Times that to the other side. Was 0.5 R plus, what would that be, 0.365? And minus that over. And then, yeah, so just solve it, right? Am I right about that being 0.65? 365? I should never doubt myself, honestly. 0.4 minus answer. And then we're going to divide it by 0.5 because that's what it says. We get 0.07. God, why can't I speak? So that's a value for R. And it also says find the value of Q. Now remember what I said. we can now use this to work out the value of Q. So Q just equals 0.22 minus 0.07, which is 0.15. So that's really, really nice. So now we actually know all the values. So that's 0.15, that's 0.07, which is handy, very handy indeed. Then it says, okay, this is going to be fun. Find P, A or B not. So it's not A or B, and it is C. Okay. So, what I like to do with questions like this is, again, when it says A or B not, first of all, I'm going to highlight A or B. Right. Now it says not, which means we are not going to use anything inside this shaded region. And then it says and it's C. So as you can see, the only parts in C that are not in A or B are 0.25 and 0.08. Which is 0.33. Cool. Then it says use set notation to write an expression for the event with probability P. So, okay, great. So I need to go back to here. So, first of all, as you can see, it's inside the region B. Now, why can't I just write it would be, B? Well, the problem is we have these additional bits, right? We have these additional parts from A and from C. So we want to get rid of A and C. So what we could do is we could say and. Now, the way I like to think of and or is whenever you have the or sign, so like A or B, did you notice how the area got bigger? So we had the probability of A or B, so it adds the area of B. Then when we had and, it reduced the area, right? Because and makes things more specific, which means it reduces the area. So what I could do is I could say, and it's not in A. And that would get rid of that green part. And then I could say, and it's not in C to get rid of this teal part here. Oh my god, that's really messing up my eyes. So simply put, P is equal to the probability of, actually does it say, it just says A, yeah, so A and not, no it's B isn't it? Dang it, I got the letters the wrong way around. It's the probability of B and not A and not C. Now of course there are other ways you could write that might be a bit more elegant. For example, I could say B and A or C not. So it's B and it's not A or C, for example. But I actually think that kind of, I would just keep it simple, right? I wouldn't try and be fancy with it, because the fancier you try and be, the more likely it is that you'll drop a mark, and it is only a single mark, so let's not worry about that. But remember, whenever you use the AND operator, it always subtracts from the area. It makes the area smaller. The OR operator makes it bigger. That brings us to the end of the stats part. So we're going to move on to mechanics. As I mentioned, this is all going to be in one video, but hopefully that stats part was useful. And let's start with mechanics. Finally moving on to mechanics, which I prefer greatly, so let's get on with it. So here we have the first question. The first question normally is something fairly simple, where you only get a couple of marks. But I would label all the forces. We have a downwards force, which is the weight, 0.5 G, and we have an upwards force, which I'm going to call R. And that's it for now, because again, there is a rough horizontal plane, but there's no horizontal force anyway, so there's no friction either yet. But in part B, you can see that there is friction. So when it says find the magnitude of the normal reaction, that's just finding what R is. So we're going to resolve vertically. The vertical force is R, and the downwards force is 0.5 G, so that's just our answer. For part B, it says the coefficient of the plane between P and the plane, that doesn't make any sense, is 2/7. A horizontal force of magnitude x newtons is applied to P, given that P is now in limiting equilibrium. So we have this horizontal force x, and that means we have a backwards force, which is mu r. Now, when they say limiting equilibrium, it means friction is at its biggest value, because normally friction, the equation for friction is this. But when you're in limiting equilibrium, or when you're actually moving, so there's an acceleration, then friction is just equal to mu r. It's at its greatest possible value. So here we're just going to resolve horizontally, and I'm going to take to the right as positive because x is going to the right. So going to the right we have x. Going to the left, we have mu r. Well, mu is 2 over 7. And we worked out r already is 0.5 g. So it's just 2/7 of 0.5 g, which, well, you know what, let's just work it out because I have no idea. 2 over 7 times 0.5 times 9.8 gives me 7 over 5, or 1.4 newtons. And that's it for the first question. Not too bad. Let's see what the next one is. Okay, so here we have a speed time graph. Again, you're probably going to get one of these. Figure 2 shows a speed time graph for a motion of an athlete running a 200-meter race. Because it's in bold, it's probably something that we need to highlight. And they start from rest, of course, at 0. Then they accelerate at a constant rate, reaching a speed of 10 at t equals 4. Then they move at a constant speed from 4 to 18 seconds. Then they decelerate at a constant rate from 18 to 24 seconds, reaching a final speed of u when they cross the finish line. Using the model, find the acceleration of the athlete during the first 4 seconds of the race, stating the units. So, for part A, in a speed time graph, the gradient of the line is equal to the acceleration. So we're literally just doing change in, I mean, if you like, it's also just change in v over t, right? Technically speaking. So it's 10 minus 0 because we end up at 10 meters per second, but we start off at 0, over the difference in the time, so that's 4 minus 0. So that's just 10 over 4, which is 2.5, and then the units are meters per second squared for acceleration in this case, because it's meters per second and then seconds along the x-axis. Part B, find the distance covered by the athlete in the first 18 seconds of the race. Well, in a speed time graph, the area under the graph is going to give us the distance, but again, we're only going up to 18 seconds. So that shape there is actually a trapezium. So we're going to work out the area of that trapezium up to 18 seconds. So area of a trapezium is a plus b over 2 times height. A and b are the lengths of the opposing parallel sides. So that goes from 0 to 18, so a is going to be 18. This goes from 4 to 18, so that length there is 14. Then it's over 2, and then it's times the height being the basically the speed in this case, times 10. So let's see if I can do this in my head. 14 plus 18 is 32, 16, 160 meters. Cool. Now, because it's a 200 meter race, we can probably expect that it should be a number smaller than 200, right? So that might be a way that you can check your answer. And then part C, it says find the value of u. Well, remember, the area under the entire graph, so including this red part over here, should add up to 200 meters because it's a 200 meter race. So logically speaking, it should be add up to 200. So if we know that everything on the left of this red shape is 160, that means the area of this shape should be 40 meters. And again, that's another trapezium. So we can once again use a plus b over 2h to work out the answer. And we know it should equal 40. So a and b, the opposite parallel sides, are u and 10. So we have u plus 10 over 2 times the height, where the height is basically the width of this shape, which is a width of 6. 40. So 6 over 2 gives me 3, so that's 3u plus 30 equals 40. Hopefully that makes sense, right? So we divide the 6 by the 2, so that's 3. So that gives me 3 open bracket u plus 10 close bracket. Then I've just expanded it. So that means u is just equal to 40 minus 30 is 10, and then divide it by 3. Does it say, we don't actually need the exact value, I think we can just leave it like that. Yeah, 10 over 3 meters per second, let's just leave it like that. There you go, not too bad. Now we're getting into a slightly meatier question, which is inclined planes. And it is a rough inclined plane, which means there's also going to be friction involved. And they give us tan alpha, of course they do, coefficient of friction, but it's less than 5 over 12. It's released from rest and slides down the plane. So that means we have an acceleration going down the plane. Friction has to be acting opposing to that. Cool, what else do we have? Well, we're going to have the weight of the object, which is going to be mg. Then we're going to have the normal reaction, which is perpendicular to the plane. I'm going to call that r. And anything else? Nope, that's all we have for now. Now, if you're ever stuck on a question like this, my number one piece of advice is just to resolve in every possible direction. So in this case, because it's an inclined plane, you probably want to do parallel and perpendicular to the plane. That would be my recommendation. So because we want the magnitude of the normal reaction, it makes sense that we're probably resolving perpendicular to the plane. And I'm going to take up and to the left as positive. So that gives me R equals, and then there's a component of the weight that acts perpendicular to the plane, where this is alpha. By the way, with the whole tan alpha equals 5/12, you can draw a right angled triangle, and the opposite side is 5, the bottom side is 12. That should be 13 if I'm not mistaken, right? You can just use Pythagoras to work that out though. Let me just, 5 squared plus 12 squared is 169. Yeah, good. So that's alpha there. So that's going to equal the adjacent side, because we want the part that's perpendicular to the plane. So that's going to be mg cos alpha. Now does it say, it says it just wants it in terms of m and g. So cos alpha, that would be adjacent over hypotenuse, so that would be 12/13. So R is equal to 12/13 mg for that one. Now for part B, it says, show that as P slides down the plane, the acceleration of P is equal to this disgusting thing over here. Cool. So if we want the acceleration, we must be resolving parallel to the plane, because that's the only way acceleration works, right? It's down the plane. I'm going to take down the plane as positive. And again, we're going to use F equals ma. The reason why we didn't use F equals ma in this case is because it's not accelerating perpendicular to the plane, it's only accelerating parallel to the plane. So F is going to be the sum of the forces acting parallel. So that's going to be the opposite component of the weight, so mg sine alpha. Because again, we're looking at this opposite side here. Minus, why is it minus? Because it's acting in the opposite direction to weight, right? Because this is acting down the plane, this is acting up the plane. Minus friction equals ma, where m is just m and a is just a. Fantastic. Now what else do we know? Well, we know that friction, thanks Ciclina. Well, we know that friction is equal to mu r. And it says mu is less than 5/12, so what we could do is just say that because it's the maximum possible value, we can just say it's equal to 5/12. So let's sub that in. Minus mu r equals ma. And again, I'm going to take mu to be 5/12. I know it says less than 5/12, but remember when they say less than, it's up to that value. So we're just going to use 5/12. So we get mg sine alpha. Sine alpha will be opposite over hypotenuse, so 5/13. Mg minus mu, which is 5/12. R, which is 12/13 mg. Actually, no, they want us to leave it in terms of mu. There you go. Okay, good. We don't need to actually use that value. That's perfect. Minus mu times 12/13 mg from part A equals ma. So now I can divide through by m. And let's see, what do they want us to do? They want us to factorize out the g and the 1/13. So if I do that, because don't forget I've already got a equals, because a is the only thing on the right hand side. So if we factorize out 1/13 g, what do I get? Well, when you factorize, you divide, right? If I do 5/13 divided by 1/13, I get 5, which is again in the answer. If I do 12/13 divided by 1/13, I'm left with 12, so we have minus 12 mu equals a. So that's not bad at all. Cool. State what would happen to P if it is released from rest but mu is bigger than 5/12. Well, all we have to do is state it, so we don't have to actually give anything. But if we have a look at this acceleration for quickly, if I make mu bigger than 5/12, what happens? Well, first of all, if I sub in mu equals 5/12, well, you might notice I get, by the way, you don't need to write this out, there's no explanation because it is just a state question, but this is for your benefit. What do you notice happens? Now again, those cancel. I get 5 minus 5, I get 0 equals a. Zero acceleration means that the object is not going to change velocity, which means if it's at rest at the beginning, then it's going to remain at rest. Now, I know that if you sub in a value bigger than 5/12, you're going to get a negative acceleration, which means it would go up the plane. The problem with that is, this is where you have to use your physics knowledge. friction can never cause motion. So friction stops motion, it doesn't cause it. So if mu was any bigger than that, it just means that you would have this, right? Where it would never get up to the maximum value. It would always be less than that value. Because again, it can't cause motion, right? So in other words, it just wouldn't move. Because the acceleration would be 0. And it would cap there, it wouldn't go any bigger than that. Okay, vectors. Vectors is often a little bit tricky for a lot of people, which is honestly fair enough because they are a bit weird, but they do actually make things easier once you really understand what a vector is and what it's doing. So R here is a position vector, so it's telling us where the object is in relation to an origin. And they give us this equation. Cool, I'm going to ignore the equation for now because it doesn't really help me yet. It says when t equals 4, the bearing of P from O, if you notice, of P from O. So in other words, the position vector will make a 135 degree angle. That's the key thing there. So again, when t is 4, the bearing of P from O, so the position vector, is 135 degrees. That means if I sub in t equals 4, the resulting vector should be at 135 degrees to the j vector, to the north line. So let's do that. Let's sub in t equals 4. I like to use column vectors personally. So this I component will be on top. So 4 square rooted is 2, that's 2c. And then 4 squared is 16 times by 3 over 8. So 16 divided by 8 is 2 times 3 is 6, but it's a negative, so it's negative 6. So if I draw this vector out now, it goes 2 to the right, and then it goes 6 down. And that means the actual vector itself, which I'm going to call R, goes like that. Now again, if we draw the north line, or the j vector, whatever you want to call it, the bearing should be 135 degrees. So what does that tell me? Well, don't forget, this here is 90 degrees there. That means the angle on the inside of this triangle should be 135, take away 90, it should be 45 degrees. So let's get rid of that. And now we know that this is 45 degrees. Again, just one more time with the logic. This thing on top should be a 90 degree angle. The total angle they tell us is 135. So that part must be 45 degrees. Now again, we can label the sides. 2c would be this adjacent component here. And minus 6, or just 6 in this case, is going to be this component here. Now it does say solutions relying entirely on calculator technology are not acceptable. So as I mentioned in the last video, this essentially means it's a non-calculator question. There's a few ways to have a look at this to do it without a calculator. There's one way, which is really fast, which is the only way to have a 45 degree angle is for both of these components to be the same. So 2c equals 6. That's one way to do it. Now, another way to do it is obviously using trigonometry, right? So opposite and adjacent, so we have tan 45 equals opposite over adjacent. Now tan 45 is just equal to 1. And then you get the exact same thing, right? You get that both of those components should be equal. So again, a few ways to do it, but just c is equal to 3 is totally fine. In fact, I'm going to write, oh, it's to show that c equals 3, that's perfect. And then it says find the speed of p when t equals 4. Now, that's interesting. A lot of students don't know when to do certain things in their in the questions. So for example, when do you use the formula r equals r naught plus vt? When do you use suvat? Because you can use suvat with vectors as well. And then when do you use this last thing? So here's the way I think of it, okay? The top one, there are 3 types of question. The top one is when you have 0 acceleration. So if they say it's constant velocity, or if they say no acceleration or something like that, you use r equals r naught plus vt. If they say constant acceleration, you use suvat. If they say variable acceleration, you're going to be differentiating or integrating depending on the question. Now, in this case, they haven't actually told us if it's variable or not, but have a look at the equation itself. Can you see that it varies with respect to time? And if I differentiate this, this 1/2 is never going to go away. It's always going to be dependent on time. Even if I differentiate 50 times, it's still going to be dependent on time. So it must be a variable acceleration question. If it helps, if you ever see a t in the definition for a vector, it's going to be a variable acceleration question. Now, this isn't always true in terms of mathematically in the future, because I could differentiate twice and time goes away. For example, if I differentiate this twice, t goes away. So then j doesn't vary with respect to t in terms of acceleration, but I does. So you can just have a look here and you can see if I differentiate this, it's never going to go away. So if it's a fractional power, it never goes away. Cool. So it says find the speed of p when t equals 4. So we're going to differentiate because, again, it's dependent on time. Now, differentiating vectors is, honestly, it's not too bad. But this will give us velocity. It will not give us speed. That's another way people lose marks in vectors questions. If they say speed, you have to take the magnitude. It's not a vector. And likewise, if they say find the velocity, it means you have to give it as a vector. You can't leave it as just 10 meters per second or whatever. So if I differentiate this, we bring the half forward. So we know c is 3, so if we write that as 3. Bring the power forward, that's 3 over 2. And that would be t to the minus a half I. And that would be minus 3 over 4, because 3 over 8 times 2 is that, t, j. And it says find the speed when it equals 4. So when t equals 4, velocity, the vector, equals, so we're going to have, you know what, let's actually use a calculator for this one. It's not too bad to do yourself, but you know what, it's better to be safe than sorry. I know what I said earlier about it being a non-calculator question basically, but with stuff like this, like arithmetic, there's no way they can tell if you used a calculator or not. So, you know, use one. It says 3 over 4, and we're going to do the same thing for the other one. Actually, do I need it for that one? No, 3 over 4 of 4 is just 3, so it's negative 3. So again, the speed, and I'll make it very clear that I'm working out a speed, just so the examiner has no excuse to deduct me marks, equals 3/4 squared plus minus 3 squared. And again, technically you should do this without a calculator, but what they don't know can't hurt them, right? For the sake of that, I would probably leave it as a surd. So we have 3 root 17 over 4 meters per second. And lastly, but not least, when t is equal to capital T, p is accelerating in the direction of, interesting, minus I minus 27j. So first things first, let's work out the acceleration vector, and we're going to do that by differentiating the velocity vector. So that gives me minus a half again, so it's minus 3 over 4 t to the minus 3 over 2, and that'd be minus, whoops, and that's I, minus 3 over 4 j. In fact, I'm going to write this as a column vector right now because this is making my brain hurt. 3 over 4. Disgusting. Ugh. You could also factorize out the 3 over 4 if you wanted to make it look a little nicer. That's something you can definitely do. And yeah, that's what we get. So, there are two things we can do here. And the way I do it is different to the way a lot of the textbook does it, and different to the mark scheme and things like that. But I also think that sometimes the mark schemes and the way the textbook does it can be confusing to some students. And because you already have access to that, I'm going to give you another way. So it's accelerating in the direction of. Here's what we can do. We can say equals that vector. But here's the problem with vectors. If I'm accelerating in the direction of this, I could have any of these vectors. I could times them both by 2. I could times them both by 3. I could times them by 0.5. I could times them by square root 3. All of those would result in something accelerating in the direction of. The reason is this. If I draw this vector, so it's minus 1, minus 27. If I double the sides of this triangle, I get a vector that's moving in the same direction, it's just longer. And can you see how I can just keep doing that? And all these vectors are accelerating in the same direction. The only difference is how quickly they're accelerating. It's how big they are. So when they say it's accelerating in the direction of, it doesn't mean it's equal to this vector. It means it's equal to a multiple of that vector. And now we can do something very clever. What we can do is equate the I components and equate the j components. So the I component is going to be minus 3 over 4, t to the minus 3 over 2 equals minus k. And then we can also equate the j components, and we get minus 3 over 4 equals minus 27k, which means I can work out what k is, sub it into the top to work out time. So k is equal to, well, first of all, get rid of the negative. Let's just call it 3 over 108. Yeah. You can simplify that, but I don't want to, so I'm not going to. Let's cancel the negatives here. So that means this is 3 over 4 capital T to the minus 3 over 2 equals 3 over 108. So I'm going to move the T up over here, and I move the numbers over here. So I'm going to times both sides by 108, so that's 3 times 108, which is 324. Divide both sides by 3 over 12 equals, when I move this up, I'm timesing both sides by t to the power of 3 over 2, so I get t to the power of 3 over 2. Then I'm going to square both sides, then cube root. So I'm going to get 324 over 12 squared, then cube rooted. Oh, come on. Then cube rooted gives me t. And that gives me my exact value, which is why I like doing it. So let's have a look at this. By the way, it is actually possible to work this out without a calculator, but once again, it's fine. It's fine. So squared rooted 9. Perfect. For 4 marks. Again, you could say that taking dividing the two components might be quicker, but for me, a lot of students don't understand why. And then sometimes there's a little bit in the question which changes it slightly, where you have to add like a minus somewhere or something like that. I think this method makes a little bit more sense when it comes to that, and it's also more mathematical in that sense as well. And of course, you have to have a projectile motion question. By the way, you have to also have a moments question, so I'm willing to bet money that that's the next question after this. But we have projectile motion, and of course we have projectile motion equations if you want to be really technical and specific for 6 marks. So let's have a look here, right? So it starts off projecting at some angle 35 meters per second, where alpha is 3, 4. So we have the opposite being 3, 4, and that should be 5, because 3 squared is 9, plus 16 is 25, square root that is 5. By the way, the reason why I use the triangle is because you get exact values. If you inverse tan this, you don't get an exact value, which can sometimes lead to some mistake. So the horizontal distance of P from O is x meters, and the vertical distance is y meters. So yeah, we don't have any information at all, but we want to have an equation for the vertical distance in terms of the horizontal distance. So again, when in doubt, you know you're going to use SUVAP because it's a projectile motion question, and you're just going to resolve vertically and horizontally. So let's start with horizontal because it tends to be the easiest. Now with horizontal, you don't actually need SUVAP because there's no acceleration. When you don't have acceleration, you shouldn't really use SUVAP necessarily. But what can we work out? Well, we have the speed equals distance over time formula. I know what speed is. It's 35, and then we're using the adjacent component, right? So that'd be 35 cos alpha. The distance, it says, is x meters, and time is just t. So let's sub that in just very quickly. Cos is going to be adjacent over hypotenuse, so 4 over 5. So 4/5 of 35, well, 35 divided by 5 is 7, times 4 is 28. So we get 28, that's it, equals distance, which is x, over time. Now, I might want to leave this for a second. Yeah. Now, some of you that have practiced your projectiles a bit, what's the only variable that's the same between horizontal and vertical? It's the time. So it might be worth rearranging this for time, but let's say we didn't know that. Let's now do vertical. Now, what do we have vertically? Well, we have s is equal to, well, it's just equal to y, right? Because it says the vertical distance above the ground is y. The initial velocity is going to be the opposite component of this. So it's 35 sine alpha, where sine alpha will be 3 over 5. So 35 divided by 5 is 7. 7 times 3 is 21. The final velocity I don't know, because I don't actually know where this point is anywhere. A is going to be minus 9.8, because it always is. And t is just going to be equal to time. So if I want an equation with SUA, we don't know v, so we must use t. So SUA and t. That's going to be s equals ut plus a half at squared. And if you actually have a look at the equation, you can kind of see that there's a quadratic, so we know we're going to use a quadratic. This is where I might realise I can rearrange for time here. And use that. So s is equal to y. Ut, so that's 21, times x over 28, which is where the 3/4 comes from, because I can divide them both by 7. That's going to be technically a minus, a half, times 9.8, times x over 28 squared. So there we get y is equal to 3/4 x, as I mentioned before. This is probably going to be minus 1 over 160, but you know what? Just in case we make a mistake, it's always worth to check. So we have 0.5 times 9.8 times 1 over 28 squared. One over 160. Perfect. And look at that. 6 freaking marks for that. 6 marks! Not bad. I know it might be tricky, but in terms of length, it's not that bad, which is why I quite like mechanics. So part B, using your answer to A or otherwise, find the length from O to A, where A is the end point. So why have they said O to A? Always think about that. Well, what happens at A? Well, y is equal to 0. Using your answer to part A. Okay, so if I sub that in, what do I get? I get 3/4 x minus 1 over 160 x squared equals 0. So if I factorize out an x, we have either x equals 0, which makes sense, right? Because it starts from the ground. So x equals 0, yeah, that makes 100% sense. Or we have 3/4 minus 1 over 160 x equals 0. Let's move that to the other side, and then times by 160. Times by 160. What am I talking about? 160 divided by 4 is 40, times 3 is 120. So again, I added 1 over 160x to both sides, then times by 160. Cool, so that means the length of OA should be 120 meters. Wonderful. That's for another 2 mark. Okay, that's not that great, I suppose. Using answer to A or otherwise, find the value of H. Now that's actually a little trickier, because that requires a little bit of understanding of what we've done here from a pure maths perspective. Because normally, if you wanted to find out the peak height, right, the greatest height above the stone, so that's going to be right here. Usually to find that, we would just use SUVAT and we would make v equal to 0. The problem is here is that we don't actually have enough information. Actually, no, we probably could do. We could say v is 0. We could use v squared equals u squared plus 2as. But it does say using your answer to part A or otherwise. Okay. So you could use that. Fair enough. You could say v is equal to 0 here. And you could use v squared equals u squared plus 2as to work out s. That's one way to do it. The other way to do it, which is fairly clever, is we have a quadratic equation, right? This is a quadratic. So when y is equal to h, that's just in between 0 and 120. It's halfway in between, because remember, quadratics are symmetrical. So the maximum or minimum of a quadratic is always halfway between the two roots of the equation. So if I just make x equal to 60, sub that in, I get y. 3/4 60 minus 1 over 160 There you go. So again, you could use suvat in that case, and it does say or otherwise. Yeah. If it did just say using your answer to part A, you would have to use the answer to part A. But here it says or otherwise, so if you wanted to use suvat, you absolutely could. That's totally fine. But this is also kind of a faster way, a little more elegant, maybe. Is that a word? 45 over 2, we get 22.5 meters. Cool. In fact, I probably should have said that that's h equals that. It's fine. Cool. Now for part D and E, it's just simple 1 markers, nice and easy, nothing too stressful. Okay. The model's refined to include air resistance. Using this new model, the greatest height of the stone is found to be k meters. Is h or k going to be higher? Okay. So, including air resistance, what will that do? What that will do is it will change the acceleration over here for vertically. It will also add air resistance horizontally, so we'll have an acceleration there. So that means in order to reach the same horizontal component for A to equal 120, you'll have to throw it harder, right? So if you think about it, imagine the wind's blowing towards you. You'd have to throw something harder to make it go the same distance. So that means our velocity is going to be greater. That means the height is going to be greater as well because you've thrown it harder. So k is going to be greater. Sorry, actually, because we have it vertically as well, h will be greater because even though we throw it harder to reach the same thing, it's still going to be slowed down vertically by air resistance. So h is greater because air resistance slows down the particle, right? So even though we're throwing it harder horizontally to get the same thing, that means air resistance is greater, so it won't reach quite as high. State 1 limitation of this refined model. When they say state a limitation, you can literally just look at any of the assumptions you've made and you can use that. But also one refinement that I always tell my students to use because it works in every single case and they very, very, very rarely put it in the question. So here, for example, we can't say air resistance because they've included it. Which is why I don't tell my students to memorize the air resistance one. It's use a more accurate value of G. In terms of something else, you could say so many different things. So for example, you could say you can include the spin of the particle because as it spins, it's going to cause differences in how it moves. You could also say that, that the limitation is that it doesn't include the wind specifically. I know there's air resistance, but there's not necessarily wind blowing it. You could also say you have to include like a third dimension. So the ball, what was it, a ball? No, a stone is unlikely to go in this perfect arc straight forward. It's going to go to the left or right slightly. What else? The size or the shape of the stone will also affect it. The stone's also modelled as a particle, which isn't necessarily the case. So anything like that will be worth it. Okay, as I mentioned, it's moments. So perfect. We get a uniform rod, which is the total length is 2a. Uniform meaning that the weight of this rod will be directly in the middle of the rod itself, so 1a either side. Rough horizontal ground, so that means there's going to be friction pointing this way. The reason why I know it's pointing to the right, not to the left, is if you think about it, if this is leaning on something, it's only going to slide downwards like this, which means friction would oppose that motion. Again, smooth horizontal peg, cool, so we're still going to have some kind of reaction force from there because it's resting on the peg. A point C on the ground, okay, cool, between the point of contact and the peg. And again, we have 4 over 3, so opposite over adjacent, so that should be 5 over there. Magnitude, okay, they want me to use the letter S. No, sorry. Yeah, no, they do. Never mind. Which actually makes sense because we do have a reaction force over here as well. So I'm fine with that. That's completely okay. And cool. There we go. That's everything, I'm pretty sure. Does it tell me what the weight is? Yeah, the mass is M. So why do people dislike moments so much? It's because you can resolve in so many different ways. So I can resolve horizontally, vertically, parallel, perpendicular. I can also take moments about any point. So I can take moments about A, B, C, the weight in the middle, I can take moments about anywhere. So there's a lot of choice that you have. But my recommendation, as always, is when in doubt, just resolve everything. Do it in any way that you can find that you need to. This is also why the mark schemes for... What the hell? The mark schemes can be a little bit weird for moments questions. Like they'll have like 10 different like equations you can use. But again, they're not meant for teaching, so that might be why. So we want to work at the magnitude of the normal reaction. Now, because there's no length, I'm going to assume that we can just... Actually, no, I'm not going to assume that. If we resolve perpendicular, the problem is we also have like this reaction force, we're going to have a force from here, etc. So what I'm going to do instead is I'm going to take moments about A. And the reason why I'm taking moments about A specifically is, if you notice, I can get rid of one of the two of the unknowns. I'll get rid of friction and the reaction force, because with moments, it's force times distance. What's the distance of R from A? 0. What's the distance of friction from A? 0. So let's do that. That will give us, we do still have to resolve this, but that's theta as well. So we're going to have mg cos theta, because we want the adjacent component because it's perpendicular, times 1, no, not 1.58, 1a. And why is it just 1a? Because remember, the weight is acting in the middle because it's a uniform rod. And that should also be equal to, because it is saying that it's in equilibrium, right? It's not moving. Equals s times 1.5a. So that means we can cancel out the a's from both sides, which is nice. Now what would cos theta be? It would be adjacent over hypotenuse, would be 3/5. So it would be 3/5 mg equals 1.5s. I actually couldn't read my own handwriting there for a second. Yeah, see, it's so hard to draw an S that doesn't look like a 5. Anyways, now we're going to divide both sides by 1.5, and that should give us the answer of 2/5. Well, let's actually have a look. There you go. So we get S equals 1. No, 2/5. What am I doing? mg. Cool. For 3 marks, not too bad. And then, of course, for part B, it says, given that the rod is in limiting equilibrium, find the value of mu. So again, we're going to try and find as many different equations as humanly possible. Now, to get an equation for, that has friction in it, we could take moments about P, for example, and that would give us an equation that has friction in it. We could also resolve vertically and perpendicular. In fact, I think that might be better. So if I resolve vertically, and I'm going to show you where some people get a bit worked up in the sense of, well, I'm going to show you actually, it might make more sense instead of me yapping. So going upwards, we have obviously the reaction force. The reason why I'm getting this is because I want the reaction force, because the reaction force will give us F equals mu R, which we can use to work out mu. God, man, had a stroke, I think. So R plus, now over here, this is the interesting bit, because people sometimes don't fully understand why we break the force down in this way. So I'm going to break it down, and it turns out that this is equal to theta up there. It's not this one over here, that's theta. And the reason is because of Z angles, basically. So if I break this down, how am I going to draw this without making this look weird? If I draw S like this, the Z angle here actually means the angle underneath here is theta, if that makes sense. It's not the angle up there. Okay? And again, if you've attended my tuition classes or you attend my class at school, then you might know how I've explained how you do this and break it down. If not, I do have a video on moment on the channel, which I'd recommend going to, but I show you the geometry as to why this angle here is theta, not the other one. But yeah, anyways, let's go through it. So we're going to have adjacent. So this is S cos theta. And that should equal just mg, which is the only thing going downwards. Yes. So cos theta again would be adjacent over hypotenuse, so it'd be 3/5 again. So we get r plus 3/5 of s, which is also 2/5 mg, equals mg, which means I can work out r by moving all of this to the other side. First of all, I want to make this, so 3 times 2 is 6, 6/25 mg. So it's going to be r equals mg minus 6/25 mg. So r is equal to, I want to say 19. And I'm not going to simplify it. I mean, I can't simplify it anyway, so that's fine. That's handy. Now again, remember, we're looking for fr equals mu r. So it means I have an equation for r now, which is nice. I want an equation for fr, which means I'm going to do the same thing, but I'm going to resolve horizontally. This is actually the way I always do friction questions when it comes to moments, because I think it's the easiest. When you use moments, it's very easy to mix up certain lengths and things like that, whereas this can be a bit more simple once you figure out why this is theta here. By the way, the reason why this is theta is the exact same reason this one's theta as well. So once again, if you don't know the maths behind it, go to my moments video, or maybe I can explain it in another video or something, just to help you out. We have fr, so friction, for real, equals, no, not equals. Yes, no, equals, because the other two are actually acting, actually no, not other two, there's actually only one other force acting to the left. This is acting straight down, so we don't resolve it, right? It's acting straight down, so it's not acting to the left. So the only part to the left is the s sine theta that we have. So now I could actually sub in mu r into this equation. So we have mu times, what am I doing? Times 19/25 mg equals s, where s is 2/5 mg, sine theta, which is 4/5. And if you notice, I can cancel out mg's from both sides, which means now I have no unknowns except for the coefficient. So if I divide both sides by 19/25, I should get my value for mu. And that's for 6 marks. So let's do that. So we have 2/5 times 4/5. I really didn't need a calculator for this, but YOLO, right? Divided by 19/25 gives me 8/19, which is the correct answer. And there we have it. There's the full stats and mechanics. So paper 3, 2024. That's everything for 2024 now done. So again, if you did find this useful, please do consider subscribing. It really does help me out. And also just let me know in the comments if this is something that's quite useful for you, where I go through and explain all of the past papers. Because with A-level stuff, I have finished all the content. So whatever you guys want, if it's A-star questions, if it's like whatever it happens to be, then do let me know. But other than that, I'll see you in the next one. Good luck with the revision.